Okay, in this presentation we are going to look at hexadecimal numbers. So this is one of the probably the first exercises you will do when carrying out hexadecimal questions in an exam. So what we're going to do is convert the following hexadecimal numbers into their base 2 equivalent, which is, say, binary numbers. Now this is really a straightforward exercise. I'll just show you how to do it briefly. We're also going to look at how to convert numbers into hexadecimal numbers into base 10, which is, say, decimal numbers. So anyway, we have four numbers here, four hexadecimal numbers, and you all notice they have subscript 16 at the end. That's just to denote that they are hexadecimal. That's one way of specifying that a number is hexadecimal. So we have 5F, AE, 1F, and B4. Okay. So the approach to take that I recommend really is that this table is set up for hexadecimals really. But the approach I reckon to take is just actually have something like this set up in your mind, or just jot it down on notes at the side of your exam script or something like that. You're probably going to be doing more hexadecimal number questions or binary number questions in a discrete maths exam beyond what we're going to do here, so it's probably worth your while. But we have three columns there. So the middle column is our hexadecimal. That's our base 16. Okay. So we have 0 to 9 and then A to F. And they correspond to the numbers 0 to 15 and base 10. That's on the left-hand side there, the first column. But also what we have there is on the fifth column is binary with 4 digits. So binary, which is base 2, I have it on the second column there. But just to be a bit more thorough, what I'm going to do is actually write it with 4 digits, and that's in column 5. Okay, so it makes it easier to follow. I have it aligned as well, just makes them all aligned. Just in case you're not familiar with the sequence there, starting from the right hand side, we go 0 1 0 1 0 1 the whole way down, and then the sequence from the next. The second to the right is 0 0 1 1 0 0 1 1, so that steps of 2. Then and the third from the right, which is second from the left, steps of 4, 0 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1, and then steps of 8. So the top half is zeros. This on the left hand side, the first 8 are zeros. The second 8 are ones. That's the first digit. Anyway, that's just a quick explanation of it. That's just how you do it very quickly. Anyway, let's get into this now. So we have the first exercise here, just the conversion steps. Convert each hexadecimal digit, which is each of the two characters, to its 4-bit binary equivalent, and combine the binary equivalents to form the full binary number. So essentially what I'm doing is reading from this table here. So I won't skip back and forth, but just let you take a screenshot of it if you want, and just have it at the side. So 5 with base 16 in binary is 0 1 0 1. And F in binary is 1 1 1 1. So combining these, we get 0 1 0 1 1 1 1 1. Okay, that's the first answer. AE in binary is 1 0 1 0, and E in binary is 1 1 1 0. So we have 1 0 1 0 1 1 1 0. Okay, 1 in binary is 0 0 0 1. Straightforward enough. And F is 1 1 1 1. So combining these, we get 1F is 0 0 0 1 1 1 1 1. Okay, and finally B4. B4 in binary is 1 0 1 1, and 4 is 0 1 0 0, and combining these we get 0 1 1 0 1 0 0. So that's straightforward enough really. It's actually taking the time at the start to just actually have the tables ready, and we go through it very quickly. So what we're going to do now is convert the following numbers into base 10. And also you notice that they're all 3-digit numbers this case, or 3 character numbers. 91E, F32, 54B, and 79D. Okay. By the way, you verbalize them character by character. You won't say 79D, because that just confuses things. There's no such thing as, don't do that in hexadecimal. Just 79D. Okay, so each step, here's the steps. Each digit in the hexadecimal number is multiplied by 16 raised to the power of its position starting from 0. So we will start on the right hand side and work left. Okay, and the first power is 0. Okay, So we have 91e, 9 times 16, and we raise that to 2. Actually, let's start again. Let's work from the right to the left. So we have, the first character is e, and we multiply that by 16 to the power of 0, which is the first in power. So anything to the power of 0 is just 1. Okay, so we have e times 1. And in hexadecimal, e in hexadecimal is 14 in decimal. So the first one there is 14. 14 times 1. Next character from the right is 1 times 16 to the power of 1. Okay, so 1 times 16 to the power of 16. 1 times 16 to the power of 1 is just 16. 1 times 16. 9 times 16 to the power of 2 is 9 times 16 squared. That is 9 times 256. A little bit of calculator work. Make sure you have your calculator. So we end up with 2,304 plus 16 plus 14, and that is 2,334. So 91e is 2,334 in decimal. So F32. Well, starting from the right hand side, we have 2 times 6 to the power of 0. That's 2. 2 times 16 to the power of 0, I should say. That's the first one. 3 times 16 to the power of 1. Okay, a bit of calculator work. That is 3 times 16, which is 48. And f times 16 squared. And f in hexadecimal is 15 in decimal. So we have 15 times 256. So piecing that all together, we have that is equal to 3,840 plus 48 plus 2, which is 3,890. Okay, so F32 is 3890, 3,890. So 2 more and we're done. 54b is b, starting with b. Let's start from the right hand side. I keep forgetting that. B times 16 to the power of 0, which is 11 times 16 to the power of 0, which is just 11. 4 times 16 to the power of 1. Okay, so that's 64. And 5 times 16 squared, and that is 1,280. So we have 1,280 plus 64 plus 11, that is 1,355. So 54b is 1,355. And finally, 79d, starting from the right hand side once again, we start off with d. That is d times 16 to the power of 0, which in hexadecimal, d in hexadecimal is 13 in decimal, so that's just 13. 9 times 16 to the power of 1, that is 9 times 16, it is 144. And 7 times 16 squared is 7 times 256, which is 1,792. So piecing it all together, add them all up, we get 1,949. So 79d equals 1,949. So that's it in summary, and that's the job done essentially. So just read through the answers there again, and yeah, we'll leave it there.